Hello everyone, my name is Andranali, the Bazooka Prophet, and today we'll be working on a very interesting video that is useful in the field of chemistry and biochemistry, talking about the steps that are involved in the thin layer chromatography. And the steps include the spotting step, the development step, and lastly, the visualization step. Now, when you are carrying out this practical, it will be wise that you understand these steps thoroughly before you go into the lab to carry out this practical on thin layer chromatography. Now, we should understand that before these steps are carried out, the sample to be analyzed is first of all dissolved in a volatile solvent. And when we talk about a volatile solvent, we simply mean a dissolvent that is easily evaporated. Now, when this sample to be analyzed is dissolved in the solvent that is easily evaporated, it produces a very dilute, very dilute solution, which is like about 1%. Now we then move to the step one, which is the spotting step. Now, please, if you have not subscribed to my YouTube channel, please do well to subscribe. If this is your first time of you viewing my videos, now we have so much videos for you that will be uploaded. We have series of videos that will help you to meet up with the current development in the field of sciences. Now we move to the spotting step. Now, in the spotting steps, it involves the transfer of a small amount of that dilute solution with the use of a micropipette. Now take note, it is transferred, that dilute solution is transferred, which is a small portion, is transferred to one end of the thin layer chromatographic plates. As you can see right on the bottom, we've taken our time to give you a summary of this video so that you can write, wash, and rewash. Now, this thin layer chromatographic plate is what we call is a thin layer of powdered silicone gel that has been coated onto a what now? Onto a plastic sheet. Take note. So it means that the thin layer chromatographic plate is a silicone gel, which is a thin layer of silicone gel that have been coated on or absorbed onto the what now? The plastic sheet. Now, please do not forget that as soon as that spotting step is being undergone, the evaporating solvent, which is the spotting solvent, quickly evaporates. And if that is done, a small spot of the material is left behind. Take note, a small spot of the material is left behind. And that will now take us to the second step, which is the development step. That in the development step, the thin layer chromatographic plate is placed on the development solvent. So we say a developed solvent. By what now? By what we call by the capillary action, which carries that development solvent upward. As you can see right on the board, that the thin layer TLC plate is placed into a shallow pool of a development solvent, which I've told you earlier. And when that is done, it travels up through what we call the capillary action. Now, please take note that as the solvent travels up the plate, it moves over. Take note, it moves over the original spot that I told you of from the initial. Now take note, a competition is now set up between the silicone gel, the development solvent for the what now? For the spotted material. Look at it. There are two things that have been noted here, and the two things are, while you are carrying out the procedure or the practical in the lab, you should understand that there will be a competition between the silicone gel and what now? And the development what now? Solvent. For what now? For the spotted what material. They will then move as we continue. Now, please do not forget that the outcome of this development step depends upon three polarities. And what are the polarities? Because the plate, which is the TLC plate, the development solvent, and lastly, the spotting material, which is the spot material. Please do not forget that the polarities of this theory should be noted. Remember that at this initial state of this uh, step, we have said that a competition is set up between the silicone gel and the development what now? The development solvent for the what class? For the spotted material. Now we continue that if the development solvent is polar enough, do not forget, the spot will move from distance from its original location. From where now? From its original location. Now, do not forget that different components in the original spot that are having different polarities, what will happen? They will move different distances from the original spot location and show up as separate spot. This is not difficult. It means that from the TLC plates in which the marked spot has been left. Remember that that marked spot was from the sample that is to be analyzed. And when that TLC is placed on a shallow development what now? On a shallow pool of development solvent, it travels up by what now? By capillary action. You understand that state? It travels up by what now? By capillary action. And when that is done, there is a competition that is set up between the silicone gel and the development solvent for the marked spot or the spot material. And as we progress, we have said that the polarities that are involved in that analyzed sample, that the components that are formed in that spot, what will happen? They will leave a mark. They will leave a mark on that TLC plate as they move a distance away from the original spot. Very easy. It is not difficult at all. Now what happened? Now when this spot has traveled almost to the top of the plate is then removed. Then what now? The solvent front marked with a pencil, and the solvent is allowed to now what? To now evaporate. Now we move to the last step, talking about visualization step. From the word visual, what you can see. Now, in the case of the last step, which is the visualization step, in terms of colored substances, it is very easy for us to be able to identify them. We just circle them ahead. They are very easy to be identified. But we should understand that most compounds, like organic compounds, are difficult to be what now? Are difficult to, they are difficult to be seen. And as such, what happened? There is now a need for what we call the visualization. Now, so that in this step, The silicone gel is impregnated or is infused with a fluorescence, as you can see right on the board, with a fluorescent material, talking about the UV, which is the ultraviolet light, is impregnated with a fluorescent material that glows under the UV light. Do not forget. And that a spot with will interfere with the fluorescence and appear as a dark spot on a glowing background. Very easy. We have said that the silicone gel is infused with a fluorescent material that will glow or that will produce a bright light under the UV light. And when that is done, whenever a spot is noted, it will interfere with the fluorescence and then appears as a dark spot. Now, under this visualization step, it is proper for us to not only make use of one method, rather two or three methods are used to be able to detect all the spots. The other one is to take another step under this processes here, which is the last step here, is that you can as well take that TLC plate and place it where now at the bottom of a solution containing iodine, and they tend to appear as a dark spot. Now, with this video, one can be able to have access to the understanding that this process or this procedure, they are very, very easy. Very, very easy. Now, starting from the first step, about the spotting, second step, the development, and lastly, the visualization step. Now, in a summary, do not forget, in a summary, we have said that the sample to be analyzed is dissolved in an evaporating water, in an evaporating solvent, which will produce a very dilute solution, and that in the spotting step, IVB done. We use a micro pipette to transfer a small portion of that dilute solution at one end of the TSC plate. And we have said that TSC plate involves a thin layer silicone gel that has been used to that has been absorbed ABXRB, and that has been absorbed onto a plastic sheet. And that when that is done, the evaporating solvent does what now? Leaves the spotting solvent is evaporated, and if that is noted, immediately it leaves a small spot of the material that is to be analyzed. Then, in the case of the development step, we said that it involved the placing of this TLC plate at a shallow pool of development or solvent, and that when it is being placed in that development solvent, what comes to mind? It should be understood that it travels up by what we call a capillary action. That it travels up. At the same time, too, a competition is set between what now? Between the silicone gel and the development solvent for that spotted material. And when that is done, it depends on three polarities of these substances, which are one, the polarity of the plate, polarity of the development solvent, and the spot material. And we have said that if the development solvent is polar enough, the spot will move some distance from its original location, and that the different components of that spot material we travel or we move at different distances from the original spot, and that they now appear as a separate spot. Please do not forget. And that with that, they are now marked or outlined. And that for we to see those spots, what do? For that most organic compounds that are colorless, we tend to impregnate or infuse a fluorescent material that can glow in the presence of a UV light onto the silicone gel, so that when there is a separation or when there is any spot that has been noted, it can easily be seen and circled out. And when that is done, these steps are now delivered. At this very point, we are done with this video. In our next video, we will go to other areas in chemistry and biochemistry. Please, we have our textbooks that are on sale, so you can always order for any of our chemistry textbooks and biochemistry textbooks. As at now, God bless you. Love you.